Hello friends, welcome back. Today we'll discuss about the transportation problem in part 2. In this class, we will talk about the modified distribution method. So we will discuss about the modified distribution method in detail in this class. In the modified distribution method, we'll test the optimality of the given solution or given initial basic feasible solution, whatever we have obtained from the either of the northwest corner rule, least cost method, or Vogel's approximation method. So we'll test the optimality for the given solution we have for the obtained solution. So for this, what we have to do, we have to check either the number of rows, number of allocation is equal to rows plus column minus 1 or not. If it is not, so we'll see what we have to do. So if it is number of allocation is equal to row plus column minus 1, then we'll say that this is not a case of degeneracy, and we'll say that we can make use of modified distribution method, and we can say that this particular condition is valid for applying the modified distribution method. So if it is not, if we can say if the number of allocation is less than row plus column minus 1, if the number of allocation is less than row plus column minus 1, then we will say that this is a case of degeneracy. And if it is a case of degeneracy, what we have to do, we will see, we will discuss. So and third case, what can be is the number of allocation is more than row plus column minus 1, and for that what will happen? So it is a case of more than one path per cell. So all these three conditions we will see in the coming slides. So first one case is the case of degeneracy, not a case of degeneracy. Second one is the case of degeneracy, and third one is the case of more than one path. So if it is a case of degeneracy, so we can resolve the degeneracy by allocating a very small values of allocation E1, E2 like that in the any of the unallocated cell. So to resolve the degeneracy, what we have to do is we will allocate a very small value, very small value E1, E2 in the unallocated cell, and we can resolve the cases of degeneracy. So we'll see these things in the today's class. So we'll start making use of modified distribution method. So for that we have a solution. We have a solution. We have obtained solution from the northwest corner method, northwest corner technique. So this is the solution, initial basic feasible solution we have obtained from the northwest corner rule, and we have to check. We have to check either this particular solution is optimal or not. So we have to check either this particular problem is optimal or not. So for that, what we have to do, we have to do some steps, and what are the steps we will see. So this question we have to check either this is the solution obtained solution is optimal or not. So either this solution is optimal or not. So we will start solving this particular problem. So first what we will do, we'll check either this is either the condition of modified distribution method is valid or not. So for that, what we will do, we will see the number of allocation. So in this case, if we'll check right now, if we'll talk about the transportation cost by calculating 55 into 18 plus 20 into 21, 45 into 22, 50 into 26, and 25 into 16. So if we'll add these things, we have a transportation cost of 4100. So what we'll do, we'll check either this particular 4100 is minimum or not. So this 4100 is minimum or not. So we'll check. So for that, what we'll do, we'll first step is, so we'll have to introduce optimal, or you can say dual multipliers or dual variables we'll introduce in row and column. So in this particular column and this particular row, we'll introduce the values of ui and uj, which will say that these are the dual multipliers. These are the dual multipliers. So we'll find the values of dual multipliers. So we will find the values of dual multipliers or ui or the value of ui and vj. So for finding the values of dual multipliers, what we will do, we will introduce zero. We will introduce zero in the maximum allocated cell. So in this case, we can say that maximum allocation in any row or in any column is 2. If we'll talk about this particular column, we have 2 allocations. If in this column we have 2 allocation, in this row we have 2 allocation, in this row also 2 allocation. So we can introduce 0 in any of the row or column which has maximum allocation. So right now we are allocating 0 for this particular row. So we will find the value of ui and uj, which are the dual multipliers or dual variables, by making use of one formula. One formula, that is the ui plus bj equals to cij. So we have a formula ui plus bj equals to cij, and by using this particular formula, we will find the values of ui and vj. So we will find the values of ui and vj by making use of this particular formula. We will make use of this particular formula only for those cells which have allocation. So we only those cells which are occupied, for those cells we will make use of this particular formula. So let us say we are going to use this particular formula for this particular cell. So this is the u2 and v2. So we can say that u2 plus v2 equals to u2 plus v2 equals to C22. So U2 plus V2 is C22. The value of V2 is 0. And we have to find the value of U2. And that is C22 equals to C22 equal to 22. So we can say that U2 equal to 22. So we have this particular value is 22. So we are not going to find every time by making use of this particular formula. What we will do is we will calculate directly without we will use this particular, but we will keep this formula in mind and we'll make use of this formula and we'll calculate directly. So how we are calculating, we can see. So we have to find the values of ui for this particular. So how we are finding this 22? This 22 will be equals to how? This 22 will be equals to this 0 and plus this u2. So since it is a 0, so this will turn it out as 22. Next we'll find value of u3. How we are finding u3? How we are finding u3? We'll see. This value is 26 and it is 0. So this 26 will be equals to sum of these and this. So 0 plus u3 will be equals to 26. So we can say that this will be equal to 26. So it is a 21. So this 21 will be equals to this plus this. So we can say that if it is a 21 and it is 22, so this will be minus 1. Since 22 minus 1 will be 20, if you will add 22 and minus 1, then it will come 21. So this is 21. It is minus 1 and it is 18. So this 18 will be equals to sum of these plus this. So this is 18, so it will be 19. And like that, if it is for this cell, we will make use of this formula only for occupied cell. So if it is 16, so and this is 26, so we will this will come it as 26, and so this will come it as minus 10. So like this way, we are finding the values of each ui and uj. So we have obtained the values of ui and uj. So we have obtained the values of dual variables for each row and each column. Next, what we will do? Next, we will find the, so we have obtained these values, each row and each column. Next, we will find the opportunity cost, that is the values of dij, by making use of this particular formula. Dij equals to this. Dij equals to this. So we will make use of this formula. We will make use of dij equals to cij minus ui plus bj, and this formula we will use only for unoccupied cell. We will make use of this particular formula only for those cells which are not occupied. So in this case, these cells are not occupied. This cell is not occupied, and this cell is also not occupied. So we will find the values of opportunity cost, that is dij, by making use of this formula, and we'll find the values of dij for these cells. So for these cells, we will find the Dij. In the same way, we have obtained the Ui plus Bj. So how we are finding Dij? So Dij will be equals to Cij minus Ui plus Bj. So how we will find? We will see. We can find the values of Dij. So right now we are going to find the Dij for this particular cell. So Dij will be equals to Cij 16 minus sum of these two. Sum of these two. So sum of these two is 19 and 16 minus 19. This will be minus 3. Again, we are going to find the Dij for this particular cell. So for this particular cell, the value of Cij is 16. So this 16 will be equals to sum of these two, sum of 19 and sum of 19 and sum of 19 and minus 10. Sum of 19 and minus 10 will be 9. So 16 minus 9 will be equals to minus 7. Again, we will find the value of Dij for this particular cell, and for this cell, the value of Dij is 15. So 15 minus sum of these two. Sum of these two is 22 and sum of 10 is equal to 12. So 15 minus 12 is 3. Again, we will find Dij for this particular cell, and for this cell, the value of Dij will be, for this cell, the value of Dij will be 15 minus sum of these two, these and these. So 15 minus sum of these two will be 25. So 15 minus 25 minus 10. So like this way, we are finding the values of Dij, or we can say the values of opportunity cost. So we have obtained the values of opportunity cost for each unoccupied cell. So we have obtained the values of opportunity cost for each unoccupied cell, like in the same way. So next we'll find the, what we will do next, we'll see, we are right now we are checking either the solution is optimal or not. For that, if all the values of opportunity cost, that is the Dij values of if all the values of Dij are either greater than 0 or equal to 0, then we will say that this particular solution is optimal. If not, we can say that the solution is not optimal. So what we will do, we will here right now, there is a negative value, less than 0 value. So you can say that this particular solution is not optimal. So what we will do, we will optimize this particular solution. How we are optimizing? So we are going to optimize this particular solution. So we'll start, what we'll do, we'll do shifting. So there is an opportunity of 10 units. If you will allocate some quantity in this particular cell, so your cost will be reduced by 22. So if it is if you are allocating, let us say 20 units to this cell, so your cost will be 41 minus 10 into 20. So like that, your cost will be reduced from the earlier cost. So how we are allocating, we will see. So right now, what we will do is we'll start. We'll form a closed loop. How we are forming the closed loop? We will start from this particular cell, and we will draw either vertical or horizontal lines. Either vertical or horizontal lines. So either we can draw vertical or horizontal lines, and we'll make turn only at the allocated cell. So what we are doing, we are starting from here, and we are drawing the horizontal lines. And turning will be possible only at the allocated cell. So this particular cell is allocated one, so we can make a turn over here. So turning we have taken. Again, we can go either this side or this side. What if you go this side, there is no option of turning. So what we'll do, we'll move this side. Again, there is allocation, so what we'll do, we can turn. So we have taken a turn. So we have plotted either horizontal or vertical line, and turning we have taken only at the allocated cell. Next, what we'll do, we'll allocate, we'll assign alternative positive and negative sign. We will start with the positive, and we will start positive from the cell having maximum opportunity cost, or we can say the cell having highest negative of opportunity, highest negative value of Dij. So we'll start plus here, then minus, again plus and minus. Next, what we'll do, we have two negative. In this case, we have two negative value. So one negative allocation is 20 unit, and one negative allocation is 50 unit. So what we'll do, we'll subtract the minimum value. We'll subtract the minimum value from this, and we will add here. Also, we will subtract from this, and we will add here. So here 20 will come. It will be 50 minus 20. So like that, this will be 45 plus 20. So what we have did in this case is we have picked the max picked the cell having maximum value of, or we can say having highest value of Dij, or we can say highest negative value of Dij, and that is minus 10. So we have started drawing a horizontal and vertical lines, and we have taken only the turning at the allocated cell, and next we have assigned negative and positive signs, and we are starting with the positive sign for this particular cell, and again we have alternatively assigning the signs positive, negative, positive, negative. So we have to shift the minimum negative value, and the minimum negative value is 20 unit. So we have shifting the 20 unit. So we have to reduce 20 from this cell, and we have to increase 20 here. Again, where there is a negative sign, we are going to reduce 20 unit, and we are going to add that 20 unit to the positive sign. So next cell we will come. So these are the steps we have followed here. So what are the steps we have followed? We will say over here. First step, we have initially introduced 0 in any row or in any column, and we have to introduce 0 in such a way that the row or column must have maximum allocation. Next, we have to compute ui and vj, and for that we can use this particular formula for occupied cell. We have to find ui and vj by making use of this particular formula, and we have to compute Dij by using this particular formula. This formula ui plus vj equals to cij only valid for occupied cell, and this formula is only valid for unoccupied cell. If we are using this particular formula for occupied cell, this is not valid, and if you are using this particular formula for unoccupied cell, then in that case it is also not valid. So we have initially introduced dual variables, and you can say dual multipliers in each column and each row. And this is Dij is the opportunity cost. Next, we'll find the value of new cost, and new cost will be equals to old cost. New cost will be equals to old cost minus number of unit transfer into reduction per unit. In this case, we have old cost. Old cost is 4,100 units minus 10 into 20. So we can say we have 3,900. It is the new transportation cost we have. Next, we will go for next step. In the same way, what we have calculated in the earlier slides. So again, we have to check either this particular new solution is either optimal or not. So for that, what we will do, we will again introduce. We have calculated the new cost by making use of this formula. So again, we will introduce the dual multipliers, dual variables, and ui and vj. And in this case, we can introduce 0 over here because maximum allocation is in this particular column. There is 3 allocations. So we have introduced initially 0 in this particular column. So u3, value of u3 is 0. So we can find the rest remaining values of u2, u1, v1, v2, v3 by making use of this particular formula. And this formula is very important. We can say that this formula is only valid for occupied cell. This formula is not valid for unoccupied cell. So for this cell, we can, if you are using this formula, then if it is 15, so this will is 0, then this will come as 15. Again, it is coming as 26, and next it is 16. So if it is 15, so 15 will be equals to 0 plus this cell, so it is 15. This is also 26 will be equals to 0 plus this, means 26 will be this. Again, if it is 16, so this 16 will be equals to this plus this. So this is 16, and this is if it is 0, then it will be 16. Next, we'll find the values of u1, u2. So how we are finding u1? So if it is 18, it is 18, and this is 15. So this will be turned as a 3. So this is 3. Now if it is 22 and this is 26, so this is equal to this plus this. So if it is 26, then this will be equals to 4 minus 4. So this will be minus 4. Again, we have to find the values of opportunity cost, that is Dij for unallocated cell. So we have 4 unoccupied cell, 1, 2, 3, 4. So we will find the opportunity cost Dij for unoccupied cell, and for each unoccupied cell we are going to find the value of Dij. So how we are finding the Dij? By making use of, by subtracting the Cij, by subtracting the Ui and Vj from the Cij. So how we are finding? So it is Dij. So the value of Cij is 21. So now for this cell Dij will be equals to 21 minus sum of these two, sum of 15 and 4. Sum of 15 and minus 4 will be 11. 21 minus 11 will be 10. So this is 10. Again, we have 16, and this sum of these two is 29. So 16 minus 29, so minus 13. So we have minus 10. This is 16, and 16 minus the sum of these two. 16 plus 3, 19, and sum of these two is 16 plus 3, 19, and 16 minus 19 will be minus 3. So minus 3. Again, this is 15, and sum of these two will be 12. 16 plus minus 4 equals to 12. 15 minus 12, this will be 3. So this is 3. The highest negative value of Dij is minus 13. So we will start allocating from this cell, and again we will form a closed loop by making use of either horizontal or vertical lines, and we are going to take turn only at the allocated cell. So we have started from this particular cell. We have drawn the horizontal line. We can stop here also, but there is, if you will turn here, there is not possibility that, then there is no possible any closed loop if you turn over here. So what we have to do, we have advances to this cell, and again we can make turn over here, and then we'll close it loop. We can form closed loop like this. So again we'll put alternative positive and negative sign. We will start assigning positive sign for this cell, and then negative sign for then again positive and negative. Out of these two negative value, minus 55 and minus 30, the least value is minus 30. The 30 is the least value. So we will shift this 30 unit to this cell, and from this cell we will shift 30 unit to this cell. So new slides, this new cost matrix will be like this. So we have shifted the 30 units from this cell to this cell, and from this to this. Again, we will find the new transportation cost, and in this case, transportation cost is 3,505, 3,510. So we can say that transportation cost is reducing. So again, we will see either this particular solution is optimal or not. For that, we will find the values of dual variables or dual multipliers, and that is Ui and Vj. So we will find the value of Ui and Vj for each cell, for each row and each column. So we are assigning initial 0 for the same column which we have assigned in the earlier slides. So we are going to assign 0 for this particular column. So we have assigned 0 in this column. So what next we will we will make use of this particular formula, Ui plus Vj equals to Cij, and we will find the values of U1, U2 like that. So we can find 15. So if it is 0, so this will come 15 and this will come 16, because this equals to this plus this, so it is 16. If we'll use this formula for this cell, so if it is 18, then 15 plus this will be equals to 18, means this will be 3. Again, we will use this particular formula for if it is 3, so we can use for this cell. So if it is 16 and this is 3, so then this plus this equals to 16, means this will be 13. So this is 13. Again, if you use this formula for this cell, this occupied cell, then if it is 22, then this 22 will be equals to this plus this, means if it is 13, then this will be equal to this U2 will be equal to U2 will be equals to 13 to 9. It is equal to 22 minus 13 is 9. So likewise, we have calculated the value of Ui and Vj in each row and each column. Next, we will find the values of opportunity cost, that is Dij, for each unoccupied cell. So we are going to find, we have 4 unoccupied cells, this cell, this and this cell, 4 unoccupied cells we have. So we are going to find the values of Dij for unoccupied cell. How we are going to find this? For if we are talking about this cell, so we can find the values of Dij for this cell is 21 minus sum of these two. Sum of 9 and 15 will be equals to 24, and 21 minus 24 will be Oh, sorry, we have found for this cell. So 16, this 16 will be equals to 16 plus 3, 19, and minus 19 minus this 16 will be minus 3. If you are finding this is 16 and this is 9. So this will be equals to 25. 15 minus 25 will be minus 10. For this, it will be minus 3. And for this is 26. And this is 13. And this is 0. So we can say 26 minus 13 plus 0 will be 13. So this is 13. So in this case, again, we have maximum, we have negative Dij, and that Dij, negative Dij is maximum value is minus 10. Maximum negative is minus 10. So this is for that this cell. For this cell, the maximum negative is minus 10. So what we'll do, we'll start from this cell allocating. We will start drawing the closed cell, a closed loop from this cell. So we'll start from here. So we have to draw only vertical or horizontal line. So we have, and we have to form a closed loop. We have to take turn only at the allocated cell. So we are taking turning right now. So this way we can form this one closed loop. For drawing the closed loop, two conditions we have to take care. One is we have to draw either a straight line or vertical line, and another is we have to take turn only at the allocated cell. So again, we are going to assign negative and positive and negative signs to the to each corner. So we will start with the positive, negative, positive, negative, again positive, again negative. Highest negative, lowest negative is the 25 units over here. Here also 25 units. So we will go for shifting the 25 units from this cell to another cell. So how we have shifted 25 from here to here and from here to here. Okay. So this is the new cell we have obtained after last matrix, last cost matrix. So in this case, right now we have number of allocation is, in this case, the new cost will be 3,260, which is the new cost. So right now, number of allocation is row less than row plus column minus 1. Here, number of allocation is 1, 2, 3, 4, and row plus column minus 1 will be equal to 5. Since number of allocation is 4 and row plus column minus 1 is 5, row is 3, column is 3, column is 3, and row is 3 and minus 1. Row plus column minus 1 is 5, row plus column minus 1 is 5, and number of allocation is 4, row plus column minus 1 is 5. Since both are not equal, so this is a case of degeneracy, and we can resolve that case of degeneracy. How we can resolve? We can resolve the case of degeneracy. How? By giving some small allocation to unallocated cell. So we are giving some small allocation, introducing E anywhere in unallocated cell. So we are introducing E over here. So now it is number of allocation is 5 and row plus column minus 1 is 5. So we can say that this is not a case of degeneracy, and we can make use of, we can apply the modified distribution method now. So in the same way, we are going to find the values of dual variables, that is ui and uj, for this particular cost matrix. So we will start finding the ui and vj. We are starting assigning 0 from this cell. So if it is 0, so we will make use of this particular formula. If it is 0, so this 0 will be, so if it is 0, so this 0 will be, this particular cell will be we will use this formula, and if it is 0, then this will be 16, and this will be equals to 22. Since it is 22 and it is 15, so this will be equals to minus 7. It is minus 7 and it is 16, so this will be equals to 23. If it is 23 and it is 15, then this will be equals to 15 minus 23, that is minus 8. So likewise, like this way, we have calculated the values of ui and uvj for each row and column. Next, we'll find the value of dij for unoccupied cell. So we have to find the dij for these 1, 2, 3 cell. So we are going to find this 4 cell, 1, 2, 3, 4 dij value. So if it is 18, then we will find in the same way we are going to find the Dij 18, then sum of these two. So sum of these two 8, so this will be 10. We have found this is 16 and sum of these two will be 16 plus 7. So this will be 23, 16 and this is 16. Sorry, 16 or minus 7, that will be equals to 9, and 16 minus 9 will be 7. So this is 7. If it is we are finding 3. If it is 26, so 26 minus 0 plus 23, then this is 3. If it is 18, then this will be equal to 10. And if it is 21, then this will be equals to 22 minus 8 means that is 14, and 21 minus 14 will be 7. So we have calculated the values of Dij, and in this case we have found that the values of Dij is either positive, is all the values of Dij is greater than or equal to 0. So we can say that this particular solution is the optimal solution, and the minimum value of transportation cost is the 3260, and the same value we can found by making use of, we have seen in the last class, the same value we have obtained by making use of either least cost method or Vogel's approximation method. So in this particular cost matrix, the values of Dij is positive, all the values of Dij is positive, so we can say that the obtained solution is the optimal solution, and we have obtained the optimal solution as 3260, and this is the minimum transportation cost, and we have obtained this particular solution by making use of modified distribution method. By making use of modified distribution method, we have obtained the minimum transportation cost. So this is all about the optimization, optimal solution by making use of modified distribution method. In this method, two things is the important. One thing is for finding the values of dual variables or dual multipliers, that is the values of ui and vj, and finding the values of Dij, that is the values of opportunity cost. And this formula we can use only for unoccupied cell, and this formula we can use for occupied cell only. So with this we are concluding today's class. See you in the next class. Thank you so much.